I want to show you one more thing with my transformers. Like I said, they're all three the same. I've got three transformers, microwave transformers. The one you've seen me use for a lot of experiments, which I've made my own secondary coil for that one. Then there's the other one I use for showing how it magnetizes steel. And I just stick the standard secondary coil that came with it on there for that. But what in my third transformer is a little different. I mean, it's the same transformer, but I've made a different secondary winding. If you notice, the secondary winding is a huge copper wire. It's about the size of my finger. It's some pretty good sized stuff. I've got a metal plate here, just a steel plate. One side of the lead from the transformer is bolted solid to this plate with a good connection. The other side I leave free, where I can adjust it. So I'm going to come around the other side and show you that big wire, huge copper wire, comes in, goes around 1.5 turns, and goes back out. And what I'm trying to show here is the whole thing is acceleration of gravity. The primary coils in all three transformers, the primary coils accelerate the AC current the same. They accelerate it the same, but it's the secondary coil caught up in that acceleration, mainly in the center of the core of the transformer, that causes it to do this. And so what I want to show is this transformer with the top off. I'm going to show you the difference between how much power this secondary winding of 1.5 turns of this big wire puts out between the top on and the top off in just a moment. My microwave transformer plugged in with the huge copper wire as my secondary coil. What I want to show you is the power it has with the cap off. When I turn it on, it's humming, but watch the sparks as this happens. There's some sparking going on, and it's quite a bit, but it's not huge. Next, I'm going to show you what happens when I put the cap on this transformer. I'm going to put the clamp on it so it doesn't vibrate, so you can see the sparks better and hear them. So just give me a moment. Okay, so now I've got my C-clamp holding my cap down on this transformer. I'm going to show you the difference in the power that the secondary coil puts out when that cap's on it to make it recycle it, like I showed you before. So, transformer on, a little louder buzz, but watch the sparks. Like I was showing with the other transformers, once you put that cap on there, it gives you 4 times the output, 4 times the current moving through whatever windings you have. You get almost 4 times. When I burnt my meters up on these, trying to meter it to see how much power the difference was between the cap on and the cap off, on this particular transformer right here, I got 12 volts coming out without the cap. Once I put the cap on, then I got 48 volts. So that was 4 times the power. Then it blew my meter. And I tried that one more time with a different meter, thinking changing my settings on my meter would protect it, and it didn't. I blew the second meter. So I know that this particular winding of this size of wire on this secondary coil, without the cap, it puts out about 12 volts. That's why it runs the motor pretty smooth, this little 12-volt DC motor. But once I put the cap on, that motor just about fries itself because it's 48 volts. It's 4 times. That's what my meter showed. 12, 48. And I won't be doing that again. But anyway, I wanted to show the difference between the caps on and the caps off of the transformers and how they work with and without the caps.